Hi, everybody. It's Professor Mitchell. So now we're going to start looking at a few sections from Chapter 6. In the trigonometry class, we cover sections 6.1 and 6.2, which is law of sines and law of cosines. We are not going to cover those sections again. Instead, we're going to look at a few sections that we didn't look at in the trig class, starting with section 6.3 on polar coordinates. The objectives in this section, you can see here, we're going to plot points in the polar coordinate system, find multiple sets of polar coordinates for a given point, convert a point from polar to rectangular coordinates and vice versa, and then convert an equation from rectangular to polar coordinates and vice versa. The foundation of the polar coordinate system is a horizontal ray that extends to the right. The ray is called the polar axis. So the polar axis would be another name for the positive x-axis in the rectangular system. The endpoint of the ray is called the pole. In rectangular, we call that the origin. A point P in the polar coordinate system is represented by an ordered pair of numbers r comma theta. We refer to the ordered pair r comma theta as the polar coordinates of P. So what this is, it's another way of representing a point instead of x comma y. And what you will find, hopefully in the next couple sections, and especially when you get to Calc 2, that there are a lot of problems that are easier to do in polar coordinates than in rectangular coordinates. So in the ordered pair r comma theta, r is a directed distance from the pole to P. And when they say directed distance, they mean that it can be negative. So it can be positive, negative, or zero. So here is the pole, also known as the origin. So instead of going to the left or to the right and then going up or down, which is what we do in rectangular coordinates, we're just going to go directly to that point. And the distance to that point is called r. Again, it's really a directed distance because it could be negative, and we'll explain how that works in a little while. Theta is an angle from the polar axis to the line segment from the pole to P. This angle can be measured in degrees or radians, although when we get to a certain point, it will usually be measured in radians. And as usual, positive angles are measured counterclockwise from the polar axis. Negative angles are measured clockwise. So the idea behind polar coordinates is you start at the pole, travel directly to your point, and that distance is called r. And then the angle between this, between the polar axis, which again you can think of as the positive x-axis, and that line that you created, that's the angle theta. All right, so for example, let's plot the point with the polar coordinates 3, 315 degrees. So let me see, I was thinking about how I was going to draw things for you. Let's try this. Okay, so the idea is first find 315 degrees, and I believe that is this angle right here. And then just travel 3 units along that line. So it would be 1, 2, 3. So I'm just going to drop a, okay, you see that red line? So that would put you right about there. All right, so let's see. Okay, so because 315 degrees is a positive angle, draw theta equals 315 degrees counterclockwise from the polar axis. And because r equals 3 is positive, plot the point going out 3 units on the terminal side of theta. All right, so again, we end up at, let's see, 1, 2, 3. We end up at this point right here. Let me try that again. I don't know that I've ever used this circle tool before. Okay, there it is. That's good. All right, so that's the idea behind polar coordinates. Let me see if I have anything else. Whoops. Okay, let's get rid of this now because that's not lined up. Oh, okay, so this is a new problem. Plot the point with the polar coordinates -2, pi. All right, so let me get my line tool up here. All right, notice that r is negative, so that's going to be a little different. So the way I like to think of this is start at the pole and forget about the negative at first, just go 2 units along the angle pi, so that would bring you out here. What the negative does is it reflects that point back through the pole. So instead of ending up at this point right here, you would actually end up over here. All right, so let me bring my circle back up. So the 0.2 pi would actually be this point right here. Ugh, messed it up. Didn't let go of the mouse. All right, let's try that again. Okay, good enough. Because pi is a positive angle, draw theta equals pi counterclockwise from the polar axis. And because r equals 2 is negative, plot the point going out 2 units along the ray opposite the terminal side of theta. So that's what we did, right? Okay, next example. Plot the point with the polar coordinates -1, pi over 2. So this time r and theta are both negative. And as usual, anytime you want to try to think about one of these problems first before I explain it, I definitely encourage that. So just go ahead and pause the video and try it. By the way, these sort of circular grids that you see in my PowerPoint, you can download those. Just go on to your favorite search engine and type in polar coordinate graphing paper or something like that. And you should get a whole bunch of things that come up. All right, so -1, pi over 2. What I am going to do, because theta is negative, that means we're going to start along our polar axis. We're going to go clockwise. All right, so we're going to go down this way. But the value of r is also negative. So instead of going down here, we're going to reflect that through the pole. And that will actually put us right there. All right, so let me bring my circle back up. That's going to be right about here. Okay. All right, so again, because -pi over 2 is a negative angle, we're going to draw it clockwise. And because r equals -1 is negative, plot the point going out 1 unit along the ray opposite the terminal side of theta. All right, so different kind of problem. Let's find another representation of 5, pi over 4 in which r is positive, but theta is between 2 pi and 4 pi. So it might be helpful first to picture where that point is. So we have a regular positive angle, pi over 4, so that's right along here. So we're going to start at the pole and we're going to go out 1, 2, 3, 4, 5 units. So that would be this point right here. All right, so this is pretty simple. All you have to do is just take your angle pi over 4 and add 2 pi to it. That's going to give you a coterminal angle that's between 2 pi and 4 pi. All right, so that's what we're doing. Pi over 4 plus 2 pi is, of course, pi over 4 plus 8 pi over 4. So that comes out to 9 pi over 4. So 5, 9 pi over 4 represents the exact same point as 5 comma pi over 4. And I would say that's maybe the biggest disadvantage of polar coordinates, is that every point has an infinite number of other ways of representing it. You don't really have that in rectangular coordinates. And that does cause a few headaches when we get into graphing equations and finding points of intersection, but you learn ways around it. All right, next. Let's find another representation of 5 comma pi over 4, that same point, in which r is negative, but theta is still between 0 and 2 pi. So remember how the negative value of r works. First of all, I want to apologize. This graphic came from the publisher, and they actually don't have it pointing at exactly the right place, do they? 1, 2, 3, 4, 5. That point should actually be right here. Let me show you where it should be. Should actually be right here where that line and that circle intersect. Okay. But this image was all stuck together. I couldn't move parts of it. So I thought I would just tell you. Okay. So r is negative, but theta is between 0 and 2 pi. So the idea is, remembering how the negative value of r works, we just need to put that along this angle. And then, of course, make the value of r negative. So what is this angle? Well, it's pi over 4 plus pi, right? Okay. So pi over 4 plus pi is pi over 4 plus 4 pi over 4. This is, of course, the angle 5 pi over 4. And as long as you make the r a negative 5, that's going to give you the same point. So another representation of 5 comma pi over 4 is negative 5 comma 5 pi over 4. All right, one more example involving that same point. We want to find another representation of 5 comma pi over 4 in which r is positive, but theta is between negative 2 pi and 0. So I think that's a little more similar to the first example. So all we have to do is just start at this angle and go this way, right? In other words, just subtract 2 pi from 5 pi over 4. All right. So pi over 4 minus 2 pi is pi over 4 minus 8 pi over 4, which is negative 7 pi over 4. So a third different representation for 5 comma pi over 4 is 5 comma negative 7 pi over 4. All right, now let's talk about the relationships between polar and rectangular coordinates. So here we have a picture that kind of shows those relationships. When you want to plot this point, if you're in rectangular, you just go x and then y. But if you're in polar, you just go directly from the pole to that point, a distance of r, and then measure this angle theta. So what we want are some equations that relate r and theta to x and y. So the first thing I wanted to remind you is about some old hippies came around here tripping on acid. Tells you that the cosine of theta is x over r because x is the adjacent and r is the hypotenuse. And sine theta is y over r because y is the opposite and r is still the hypotenuse. So if you multiply both sides of both of these equations by r, you get that x equals r cosine theta and y equals r sine theta. So these are the equations that you're going to use whenever you want to convert polar to rectangular. You have an r and a theta, and you want to come up with x and y. Now to go the other way, you just use the Pythagorean theorem, which of course tells you that x squared plus y squared equals r squared. So if you have x and y, you can easily find r. And then to find theta, I want to be a little careful how I say this. The other part of Some Old Hippies Came Around Here Tripping on Acid says that the tangent of theta is y over x, because y is the opposite, x is the adjacent. So if I have x and y, I can find the tangent of theta. All right, there's a reason I'm not writing this as theta equals the inverse tangent of y over x. And that's because, remember, inverse tangent will only give you an angle between negative pi over 2 and pi over 2. So if theta happens to be in quadrants 2 or 3, then that's not going to work. So I want to leave it as tangent of theta equals y over x. And then I will worry later about putting it in the right quadrant. And you'll see that in at least one of the examples, I think. All right, so to convert a point from polar coordinates, r theta, to rectangular coordinates, x, y, you use those first two formulas, x equals r cosine theta and y equals r sine theta. So for example, to find the rectangular coordinates of the point with the polar coordinates 3, pi, r is 3 and theta is pi. So x, which is r cosine theta, would be 3 times the cosine of pi. And of course, the cosine of pi is -1. 3 times -1 is -3. So the x coordinate of this point would be -3. And the y coordinate would be r sine theta, which would be 3 times sine theta. The sine of theta is 0. 3 times 0 is 0. So the y coordinate of this point would be 0. The rectangular coordinates of this point would be -3, 0. And if you practice drawing this point on your polar graph paper, I think you'll see that it aligns with what you normally think of as -3, 0, the rectangular point -3, 0. All right, here's another example. This is a great one for you to try if you want to pause the video. Find the rectangular coordinates of the point with the polar coordinates -10, pi over 6. So that's going to work exactly the same way. R is -10, theta is pi over 6. So x, which is r cosine theta, would be -10 times the cosine of pi over 6. The cosine of pi over 6 is square root of 3 over 2. -10 times square root of 3 over 2 is -5 root 3. And y, which is r sine theta, would be -10 times the sine of pi over 6. Sine of pi over 6 is 1/2, so that would give you -10 times 1/2, which is -5. So the rectangular coordinates of this point are -5 root 3, -5. Okay, so now we talk about going the other direction, converting from rectangular to polar coordinates. First, you want to actually plot the point x, y, and that's important because at the end there in step 3, it's going to be very important to know which quadrant we are in. All right, so you plot the point x, y, and then find r by computing the distance from the origin to x, y using the distance formula. And finally, find theta using tangent theta equals y over x with the terminal side of theta passing through x, y. All right, so for example, let's find the polar coordinates of the point whose rectangular coordinates are 1, negative square root of 3. So you see we've plotted that point there. So now we will find r by computing the distance from the origin to x, y using this formula. R equals the square root of x squared plus y squared. Substituting 1 for x and -root 3 for y, you get that r equals 2. and then find theta using tangent theta equals y over x. Y over x is negative root 3 over 1, which is negative root 3. And the value of theta that satisfies tangent theta equals negative root 3 is 5 pi over 3. If you take the inverse tangent of negative root 3, you'll get negative pi over 3. But remember, they said they wanted the value of theta to be between 0 and 2 pi. So you take that negative pi over 3 and add 2 pi to it, if you find it that way using inverse tangent. All right, so one representation of 1 comma negative root 3 in polar coordinates is 2 comma 5 pi over 3. That would be the only representation where r is positive and theta is between 0 and 2 pi. All right, so now let's start looking at equations in polar and rectangular. A polar equation is an equation whose variables are r and theta. To convert a rectangular equation in x and y to a polar equation in r and theta, replace x with r cosine theta and y with r sine theta. So for example, let's convert the following rectangular equation to a polar equation that expresses r in terms of theta. So the rectangular equation is 3x minus y equals 6. Of course, that's the equation of a line. So if we replace x with r cosine theta and y with r sine theta, we get 3r cosine theta minus r sine theta equals 6. Remember, we want to solve this equation for r. So the next step will be to factor out r. That gives us r times 3 cosine theta minus sine theta equals 6. And now if you divide both sides by 3 cosine theta minus sine theta, you get the equation that you want. So this expresses r as a function of theta. Notice that the rectangular equation is much simpler than the polar equation. So in general, lines are usually easier to express in rectangular, but there are certain kinds of equations you'll see here pretty quickly that are actually simpler to express in polar. All right. So I believe this is an example actually. Convert the following rectangular equation to a polar equation that expresses r in terms of theta. The equation is x squared plus y plus 1 squared equals 1. That is the equation of a circle, right? Okay, so replacing x with r cosine theta and y with r sine theta, we get r cosine theta squared plus r sine theta plus 1 squared equals 1. So now we'll start playing with that equation by actually squaring those expressions. This thing here turns into r squared cosine squared theta. And then just be aware that what's happening here to turn this into this is that we're squaring the binomial. So if you want, you can think of that as FOIL. Squaring that binomial gives you r squared sine squared theta plus 2r sine theta plus 1. And then we still have our equals 1 over here. Now we're going to factor r squared out of the first two terms. That gives us r squared times cosine squared theta plus sine squared theta. Hopefully you can see where that part's going. And then we still have the 2r sine theta plus 1 equals 1. All right, and of course cosine squared theta plus sine squared theta equals 1. So that turns into 1. All right, and now we will subtract 1 from both sides. That gives us r squared plus 2r sine theta equals 0. So we're almost there, okay? What we're gonna do now is factor r out of this left-hand side of the equation. That gives us r times r plus 2 sine theta equals 0. And that means either r equals 0. R equals 0 is just a description of the pole. It's a single point, okay? So we might be able to disregard that. Of course, the other possibility is 2 plus sine theta, r plus 2 sine theta equals 0. So subtracting 2 sine theta from both sides of this equation, we get r equals negative 2 sine theta. We can disregard the r equals 0 because this circle actually already passes through the origin. So this is just sort of extraneous information that we don't need. It's already included in this equation. So the polar equation for x squared plus y plus 1 squared equals 1 is r equals negative 2 sine theta. So that is the equation of a circle in polar coordinates. When we convert an equation from polar to rectangular coordinates, our goal is to obtain an equation in which the variables are x and y rather than r and theta. So we're going to use one or more of the equations that we talked about earlier. R squared equals x squared plus y squared. R cosine theta equals x. R sine theta equals y. And tangent theta equals y over x. To use these equations, it is sometimes necessary to square both sides, to use an identity, to take the tangent of both sides, or to multiply both sides by r. So just like with anything else, you get better at this with practice. You start learning what the tricks are. All right, so let's convert the polar equation r equals 4 to a rectangular equation in x and y. So we're going to start with r equals 4, noting that r squared equals x squared plus y squared. If r equals 4, that means r squared equals 16. I would rather have an r squared there than an r because I know what to do with r squared. I can just replace it with x squared plus y squared. So the polar equation r equals 4 in rectangular coordinates is x squared plus y squared equals 16, which is the equation of a circle centered at the origin, which makes a lot of sense when you think about the fact that r equals 4 is just going to describe all the points that are 4 units away from the origin. That would give you a circle. And there's that circle. All right, next, let's look at another very simple polar equation when theta equals a constant. Convert the polar equation theta equals 3 pi over 4 to a rectangular equation in x and y. So remember the formula tangent theta equals y over x. If we take the tangent of both sides of this equation, we will then be able to replace tangent theta with y over x. Notice that the tangent of 3 pi over 4 is negative 1. So now if we replace tangent theta with y over x, we get y over x equals negative 1, which means that this polar equation theta equals 3 pi over 4 is just the rectangular equation y equals negative x. So that's the equation of a line. And there's that line. So this is all points which have a theta coordinate of 3 pi over 4. This part of the line in quadrant 2 would be where r is positive, and this part of the line in quadrant 4 would be where r is negative. So the simplest types of curves to describe in polar coordinates are circles centered at the origin and lines passing through the origin. All right, now let's convert the polar equation r equals negative 2 secant theta to a rectangular equation in x and y. If we start with r equals negative 2 secant theta, remember that the secant is 1 over the cosine. So that's the same thing as r equals negative 2 cosine theta. If we multiply both sides by cosine theta, we get r cosine theta equals negative 2. which I'm excited about because, of course, r cosine theta is just x. So in rectangular coordinates, this equation is x equals -2. It is a vertical line. So vertical lines do not have simpler equations in polar. All right, simplest place to do a vertical line is in rectangular. All right, I believe this is the last example. Let's convert the polar equation r equals 10 sine theta to a rectangular equation in x and y. So this is a perfect example of something that the first time you do it, it seems pretty complicated, but then once you learn the trick and you do a few more, it definitely gets easier. So we start with r equals 10 sine theta. And here's what I'm thinking. I'm thinking two things. Number one, I really wish this r was an r squared. And I really wish this sine theta was an r sine theta. I wish this r was an r squared, and I wish this sine theta was an r sine theta. Well, I think I can make my wish come true if I just multiply both sides of this equation by r, right? That will give us r squared equals r times 10 sine theta, which is r squared equals 10r sine theta. So now I'm going to turn that r squared into x squared plus y squared. And I'm going to turn the r sine theta into y. All right, so we get x squared plus y squared equals 10y. And now to put that in the form that we are the most used to, think way back to chapter 1 when we talked about, well, I don't want to give it away. All right, subtract 10y from both sides. Hopefully you're starting to see what this is the equation of. And now I'm going to take this -10 and I am going to complete the square. Remember how that works? Let me get my text box up here real quick. Oops. I'm going to take that -10 and divide it by 2. And then I'm going to take that -5 and I'm going to square it, which gives me a magic number of 25. I'm going to add that 25 to both sides. And the whole point of doing that was now I can take this y squared minus 10y plus 25, and I can write it as the square of a binomial. X squared equals y minus 5 squared equals 25. So hopefully at this point you recognize that's the equation of a circle. So circle centered at the point 0, 5 with a radius of 5. So this is really kind of the backwards version of the problem that we did a little while ago, except we were converting from rectangular to polar, right? It was x squared plus y plus 1 squared equals 1. And the polar equation turned out to be r equals -2 sine theta. So this is kind of like that, just going in the other direction. So the rectangular equation for r equals 10 sine theta is x squared plus y minus 5 squared equals 25. And there you see the graph of that equation. And that's going to do it for section 6.3. In the next section 6.4, we will continue talking about graphing in polar coordinates. So we'll see you then.